Welcome, everybody. Thank you for coming to the session. We're going to cover the Windows Package Manager, also known as WinGet, and we're going to cover Microsoft Desired State Configuration and help you get your box set up easy. I'm Demitrius Nelon. I'm a product manager at Microsoft. I work on a lot of the products that you probably love as a developer, same teams that give you PowerToys, WSL, Windows Terminal. And today I've got Steve Lee with me from the PowerShell team.
Hello, I'm Steve Lee. I'm the Principal Engineer Manager for PowerShell, also OpenSSH on Windows, PowerShell Gallery, and also Desired State Configuration.
So we're going to be covering a bunch of different topics today, starting out with kind of configuration as code, what that is. We're going to get into how WinGet applies that. Then we're going to go a little bit deeper under the covers into the Microsoft Desired State Configuration engine, the anatomy of a DSC resource, and how to actually build one yourself. But we're going to start out with why did we do this? So we did a lot of research, and we got 3 top complaints from developers. Number 1 was, my internal wikis and documentation are outdated, the steps are broken. You know, we all know we build all this documentation, and then 6 months or a year later, we onboard somebody new. Everything is out of date. URLs are broken, steps are weird, and we all tend to make mistakes when we're trying to follow complex instructions. So if we go to configuration as code, this is literally just artifacts checked into source control. The example that I would use is you fork the GitHub repository, clone it on your local, you go into the config directory, and there's a WinGet file in there, and you just run that configuration. It's going to install all the tools that you need. It's going to modify your Windows settings, do things that need to happen to the path or the environment. You know, pretty much everything you want. We've got a ton of samples and examples out at GitHub. The https aka.ms/WinGet samples redirector will take you into the WinGet DSC repository, where we're building a bunch of the PowerShell class-based v2 resources, and we'll be updating documentation there with all the exciting new v3 stuff that we've got. So with WinGet, we use YAML files for package manifests. We have moved that kind of same concept over into the world of configuration. You know, everybody loves, you know, YAML versus JSON versus XML versus whatever. We just picked that because that's what we're doing. And it's pretty interoperable with JSON behind the scenes. It's theoretically a little bit easier to reason over and understand. You're going to be able to do everything I was saying, from installing packages, uninstalling them, guaranteeing you've got certain versions of things, making sure you've got settings there. We've also got some helpers to do kind of test behavior to see if your system's in the right state or not, and it will only do those things that need to be done. So we're not just, you know, re-downloading and reinstalling everything every time we do anything. So let me jump in and give you a quick demo. So I have a demo configuration here. I'm going to go ahead and open this up in Visual Studio Code so that we can see exactly what's going on in the file. The top few lines here are really covering that I want to use WinGet with DSC v3. Right now, this is an experimental feature, but the bits are available on GitHub, so you can actually download and do everything I'm doing today. So we start out with some Windows settings. And you'll see I'm going to change my apps and my Windows to dark mode. I'm going to make sure developer mode is turned on. And I'm going to left align my taskbar. And then below here, I've got a few packages, PowerShell, PowerToys, and Windows Terminal. That's want to make sure they're installed on my system. So I can do WinGet configure demo.winget. That's going to open up that configuration file. WinGet is going to analyze the syntax, make sure it looks valid. It's going to go through and make sure that all of the resources that it needs to take action are available on the system. It's going to display all of the information to me so that I can see what it's doing. Then I get this big yellow warning. This is important. Some configurations will specify elevated context, and it'll give you that single UAC. These files can do anything to your system if they're given permissions. They can format your hard drive, they can exfiltrate data. You really want to know where they're coming from and what they're doing. So in this case, I'm going to go ahead and hit yes. I'm going to get my UAC prompt just the one time. You'll see the shield next to the title there for Windows settings. That's showing that this is a resource that needs to run elevated. And what it's doing now is it's actually moving the taskbar to the left, putting me into dark mode, going through and verifying that I have all of these other packages installed. And it's successfully applied. So I'm going to jump back into the presentation real quick. So one of the things that we don't want to have to do is figure out how to manually write these files. Like I've got my environment set up the way I like it. I just want to be able to get this configuration file checked into source control or USB drive or sneakernet or whatever to somebody else to help them get set up. That's kind of a non-trivial activity to do it manually. So what we've done is we've built an export function. It's going to go through and look at everything that's installed on your system. It's going to grab all of the Windows settings that are available through our PowerShell module for Windows settings. And for any package that is DSC v3 capable, which we'll be talking about how to do that a little bit later, it will also grab all of their settings. And I'm going to give you an example and show you what that looks like. So I'm going to just do a full export of everything. I do have a configuration on my system for WinGet where I have several different settings and other features, but I'm going to go ahead and kick this export off and talk about it, and then I'll go show you what those are. So the first thing it's going to do is it's going to say, hey, I know WinGet is a DSC v3 resource. Let me grab those user settings, get that into the configuration file. Then it knows we need to go get the Windows settings, so we use that PowerShell module to go grab all of those settings and pull all of those into the configuration file. Then WinGet looks at all of the configured sources. And on this device, I have the default WinGet community source as well as the MS store. And I've added a private REST source that is just for build, so I can show some of the capabilities for what it would look like for you to be in an enterprise. You can stand these up with Enter ID so that only authorized people can get at these packages. The IT organization can lock that source down and guarantee they know what packages are in there, and WinGet can honor all of that. So if I go into that configuration file, you can see how long it is with the thumbnail view on the right-hand side of the screen. And as I talked about, all of my WinGet settings have been pulled in from my settings file. So you can see on lines 14 and 15, I've got the configuration export feature enabled and DSC v3 enabled. I've also got some visual settings. Everybody's favorite seems to be the rainbow progress bar. And I've also got Sixels enabled so that I can see icons in the terminal. Below that, we grab the Windows settings. You can see that it grabbed dark mode and left align since that's the way the system was configured when I ran it. And then you can start seeing a bunch of packages that are coming from the default WinGet source, starting with Git. And if I scroll down, you can see it literally exported everything that it found. And we get all the way to the point where I've got a REST source. It actually knew that source was configured. It exported that. It knew it needed to be elevated. And then below that, you can see that I'm actually using the build source, and we know that we have a dependency that that REST source has to be configured first. Go down a little further, and you can see some packages from the Microsoft Store. So for the actual live demo, I'm going to run on another device for you. I'm going to go ahead and open up another window. And this time I'm going to specify I just want the packages from the build source. It'll go through that same process. So I'm going to go back and show you the settings. If I run WinGet features, I can see all of the enabled experimental features. These are the ones that matched my settings. If I run WinGet settings, it's going to open up my WinGet settings file. It's just the JSON file. You can see those settings here. These are the settings that you're going to want to configure if you want to run this same kind of a demo yourself. There is one manual step. I'll get that documented on the GitHub repo, the WinGet DSC, under the samples. That's essentially just running a command that's going to add the resource JSON files that are necessary for DSC to execute. By the time this goes GA at the end of June, we don't expect you're going to have to do any manual steps. It's just going to be baked in, no experimental features needed. So now I've got my export updated for the file. And if I look in here, you'll see this file is much shorter because it's only exporting those things from the source that I specified. Delete the one on the desktop. And move the other one over to the desktop so that I can copy this file. So we're all in on configuration as code. I've just connected into a Microsoft dev box. These are already set up. You've got all of your IT policies from Intune governing them. They're all in Azure. The team that's building this is the same team that's building Visual Studio and a lot of those developer tools. It's all configuration as code. One of the things you end up with, even though your tools are there, your source control is there, everything's ready to go, it doesn't look and feel like the way you want it. So what I'm going to do is I'm just going to copy that configuration from my desktop over. I'm going to go ahead and just double click it in this case. We have a handler for the .winget extension. So if you double click it, we'll launch your default terminal and we'll just run that configuration file. It's the same exact setup and configuration behavior that you've seen a couple of times now. You'll see what it's going to do is make sure that my WinGet settings are the same as they were on the export, make sure that my Windows settings are the same, and make sure that I've got those packages from the build source configured on the system. So I do the accept on the UAC for the Windows settings, loads up that module, goes to apply those settings. We should see the icons shift left and go into dark mode. And then after that, it's going to go through and verify that those WinGet packages are installed. So there you see crazy changing Windows settings live on stage, no harm, no foul. I did notice a bug last night. External monitors don't pick it up, so we're going to get that fixed. But the module's still in preview today. So everything is set up. I've run my export. My dev box is ready to go. So we're going to go back to the deck. And I'm going to hand it over to Steve Lee to discuss Microsoft desired state configuration.
So hopefully one of the key takeaways you've already kind of figured out is that all these demos you've seen so far is WinGet collaboration with DSC and how the two integrate with each other. So what this diagram represents is that you would start with WinGet, and that's going to know that you're going to run a DSC. And when I say DSC, actually it's a v3 configuration. And then obviously WinGet itself is a resource, so it needs to call out into another instance of WinGet to do the package management operations. And then the Windows settings today is implemented as a PowerShell script. So it has to spawn off PowerShell to do that work. So what exactly is Microsoft desired state configuration? So before I get into some of these content, if you're familiar with DSC v2 or v1, v3 is really a big reimagining of how do we get more of the developer community involved with desired state configuration or configuration as code. So there's really three kind of pillars that we looked at. The first one is really, DSC is simply a way to make it so you can consistently expose your settings from your applications. So this diagram shows your application, or it could be a service, in the middle. And historically, you probably have it stored in the registry, maybe in a text file, JSON file, maybe in a database. It doesn't really matter. On the left side, you see, using WinGet, it discovers DSC. And then DSC uses this thing called a resource manifest to find your settings. And we'll talk more in detail what that looks like later. So one of the key things of v3 is that, guess what? You don't have to write your resources in PowerShell. You still can, but you don't have to. So if your development team prefers C#, Rust, Go, it doesn't really matter. As long as it's callable from the command line, then you can use it as a DSC v3 resource with some restrictions, which we'll get into. Another difference between v2 is that, obviously, you've seen the demo. We have an export capability now, which didn't exist before. But also with get, set, and test, you're not required to implement all of these. You just implement what's appropriate for your resource. Now, obviously, if you implement more, your resource will be more useful. But for example, there's an OS info resource that ships with DSC that is only for retrieving information. You can't set like the OS architecture, stuff like that. So if that makes sense, then do that for your resource. And also, you don't even have to implement test. So if you don't need special casing for validation that the desired state matches the actual state, so for example, for a package manager, if the desired state is that your package is between versions 1 and less than 2, right? You can express that in a configuration, but DSC engine doesn't understand that syntax. So what DSC does for a synthetic test is really comparing the inputs and outputs, and I believe it is case sensitive. But as long as the output is a superset of the inputs, then it's assumed to be in desired state. But if you have either performance optimizations or other criteria, you implement test yourself. The transport between your resource and the DSC engine is just standard input-output, right? This is why if your thing is callable from command line, you just output to standard out, and it's going to be JSON lines. Now, DSC engine itself is also a configuration orchestrator. So what this diagram represents is that on the bottom is like the WinGet configuration document or DSC configuration document. And you can kind of see in this simple case, it's kind of visualizing you have 3 resources in your configuration, and there's a particular sequence that has to be enacted, right? Because again, you may have to install something first before you can install something else or other cases. Now, DSC configuration documents, which can be in YAML or JSON today, they are derived from ARM templates. So if you're familiar with the ARM template syntax, then this should feel right at home. This means that you get stuff like sequencing. So this is the depends on. You also get parameters, which I'll show a demo of that later. Variables, so if you have stuff that you want to reuse throughout your configuration, not have to type it again. Or also expressions, so this allows you to do like conditional things, other logical things within the flow of your document. And the document itself can also be used with get, set, test, and export. And again, one of the key value propositions of configuration as code is this thing called idempotency. Basically means you can continuously reapply the configuration and there'll be no side effects. Now, we do have some derivations from ARM templates because ARM, being focused on infrastructure as code or as a service, is going to be different from on the machine itself. So for example, we have this new thing called assertions. So at the top, or it could be technically anywhere, but you can make a dependency sequencing. You could have it do checks on the system, like is it Windows, is it Linux, is it Mac OS, is it 64-bit, stuff like that, before it actually runs the rest of the configuration. We've also started adding new custom functions that don't exist in ARM. So for example, you may want to get the environmental variable like path or program files, whatever the case may be, the path to a resource, right? So you can do that. And also we have this new one called system root. This is a little bit more advanced, where if your resource supports modifications at the file system level, what system root provides is an ability to actually deploy a configuration on an offline operating system. Offline here means, for example, like a mounted VHD, right? So you can imagine a case where you could potentially service or update or like disable drivers, services, whatever the case may be. But the resource has to support it. There's no magic here. And finally, one of the new things that we've added in V3 recently is this concept of extension. That means that as developers, if there's some capability in DSC that you need, but may not make sense to have as part of the core engine, we now have an extension mechanism. The last pillar for DSC V3 is really, we're building this as a platform and not a complete end-to-end solution. So we're trying to think about how do we make it easier to integrate with higher level tooling. So for example, Azure Machine Config uses DSC V2 today. Puppet Chef also uses DSC V2. And of course, WinGet is now using V3, right? So we've made some design decisions to make it easier. It is a command line tool, but the same as the way your resource communicates to DSC, the way DSC communicates with a high-level tool is via JSON lines via standard I/O. But this also includes not just the results of the operation, but also tracing information like error messages, warning messages, but also progress. So as things progress, we actually emit it as JSON so that WinGet, for example, can present it in a more beautiful way. We've also done some convenience features in the engine based on our learnings working with the Azure Machine Config team. So for example, we always do a get before a set operation. That way, we kind of make it easier for idempotency, right? Like if your system is already in the desired state, we don't actually need to execute the set operation for this particular resource. Also, it turns out that often after you've done a set, you want to see exactly what actually happened, right? So do a get afterwards and return that information as well. I mentioned about the synthetic test already. And also, and we're going to grow this over time, for example, elevation check. We don't need every resource or configuration to detect it themselves. So we do have some metadata you can add at the top of your configuration, say, this configuration requires elevation, or you can even say this configuration requires you not to be elevated because you want to run as a normal user. And as part of the collaboration integration with WinGet, what you're really getting is a familiar CLI experience, right? You saw the demos, and there's kind of no specific DSC stuff in there. WinGet is also just everywhere now, right? It's part of desktop Windows Server 2025. And again, because of the integration and design for higher-level tooling, you get a richer user experience with WinGet versus if you use the DSC executable directly. So the call to action here for this audience is really, if you want to participate in WinGet configuration, you quote-unquote simply need to expose your settings via DSC v3 or v2. So let's go into a little bit deeper into what exactly is, Let's go back here. Oh man, see now you move stuff around.
Should be on the left.
Okay, so this is what a resource manifest is, and this is the actual resource manifest from the DC repo for the Windows registry resource that we ship. And what you can see is it is just a JSON file. Technically, it could also be a YAML file. And it's pretty simple. Basically, there's a particular schema that you have to adhere to, and the resource manifest informs DSC engine everything it needs to know what to do when a user requests a get, a set, or test, or export. So you can kind of see there's some key stuff here, like description tags, just making it easier for users to find what they need. The version. So in the case of get here, the key part is you advertise that this resource registry supports get. And the way it works is that you specify the actual executable. So you could have a different executable for get, set, test, export if you need to. And then you have different arguments. So what this part informs the engine is there's an argument on the registry executable called -- input. And basically it says, even if the user provided no input, because that is possible, do send like an empty JSON payload because it expects that argument to always be there. You kind of see something similar for set. So delete is a new thing that we introduced in v3. So if you're familiar with DSC v2, you would kind of come across this thing called ensure, and it says absent and present. So this is how you kind of remove things or make sure things exist when you do a set operation. In the v3 world, I think a lot of developers think more in terms of CRUD, right? So it might be easier for them to, rather than in their set code, check for exist, which is the new term we use, they just implement delete. And then the engine will note that your resource implements delete, and it'll turn that set exist false into a delete operation and calling your resource. What if provides an opportunity where if the user wants to say, hey, what is this configuration potentially going to do on my system? If you don't implement what if, then the only thing the engine knows is currently it's A, the user wants B, and that's what's going to happen. But if you can do more checks, like for example, you can check permissions, you can check if something actually exists, you can provide a more meaningful message to the user about what's going to happen to make it become the state they want it to be. And finally, the last two sections, the exit code. So again, because it's command line based, 0 always means success, and non-zero always means failure from a DSC engine expectation perspective. And the more details you can provide here, then the more information we can pass to the user when things don't succeed. And finally, schema, and we'll get more into JSON schema in a bit, but this is how DSC validates that the inputs matches what your resource expects. Let's go back to the presentation here. So let's talk a bit about what are some of the best practices that we've learned through this whole process. The first one is, because everything's JSON based and we want users to kind of have expectations set, we want to generally use camel casing in this case, and also make sure that your property or settings are self-describing. So it's okay to be verbose. What you see in the screenshot on the top right that's the Windows GUI for settings. And on the bottom right there is the naming choices, basically the WinGet and partner teams did in terms of producing the Windows settings resource. What you really want is that if a user sees a configuration file, they don't have to open up your SDK or documentation and understand what's going to happen within that section of your resource. I kind of mentioned some of these already. So in DSC, we do have what we call canonical properties. So these are basically properties that we define with specific meaning. So if you implement it, then they should adhere to the same semantics. That way the users have no surprises. Currently we have 2. So _exist replaces the DCV2 apps ensure property. So this is true or false. By default, if it's not specified, it's implicitly true. I mean that if you have a bunch of stuff and you don't specify exists, you expect it to exist. Clobber is the opposite, where if you have, let's say, 10 settings and a user provides 2, then basically clobber means if true, it means, hey, I only want to set these 2, and everything else, set it back to whatever the default behavior is, or whatever that means for your application. If clobber is false, which is the default, so if not specified, clobber is false by default, it means only touch these 2 settings, leave everything else the way it is today. One other thing I'll mention is in your own design of naming your settings, do not use the underscore prefix. That is reserved for DSC. That way users have an expectation that they see the underscore, it is something that they can look up in the DSC documentation. So some resources can handle what we call scoping. So for example, WinGet, they can install for both the user and for the system. So if you do have such cases, the expectation is default to the current user, and if you need to do something system-wide or all users, then make it an explicit property. We'll probably have like an underscore scope type of canonical property in the future for this. Now, if your resource handles multiple instances, so for example, if you have a resource for IIS and there's a lot of websites, what you may not want to do is require the user to specify your resource and its properties in multiple places. It may make more sense that they can specify an array of objects. One of the benefits of this approach, besides having to type less, is that DSC won't have to spawn your resource every instance, but also if there's an opportunity within your resource to do like things concurrently, you can have a huge performance improvement. Now, as you start developing and thinking about how to expose your settings in the DC way, you may end up discovering that you have a lot of settings. You have like 100 settings or something like this, right, or maybe more. It's best not to have like one object that has like 100 properties or more. Instead, you should really think about logical grouping. So there's a couple of different ways to do this. One is, does it make sense that you have multiple resources, right? And by the way, you can have multiple resource manifests for the same executable, right? So you don't need to have different pieces of code. You can have one piece of code, but different resource manifests that indicate they're logically different resources. But also, nested objects may also be appropriate. You don't have to have shallow objects. We are developing, configuration authoring tools. So that with IntelliSense, some of these concerns about deeply nested stuff will go away. Now, obviously, if you go like super deep nested, that's not a great user experience either. I mentioned JSON schema. So the way DSC today works is that when you run the configuration, it is using JSON schema to validate, is this document, the configuration document, valid per what we understand it? But also, it's going to look at all the resources, and then it's going to query every resource for their JSON schema, and it's going to validate the inputs against that schema before it actually calls your process, right? So your process can be assured that the JSON inputs are going to match. Now, DSC engine also validates the outputs so that the user and higher level tools also don't get surprised. So the inputs and outputs should adhere to your JSON schema. We do recommend using the last stable version of JSON schema, which is 2020-12. Now, as we're developing these authoring tools, like in VS Code in the future, then if you put more information in the description in your schema, then we can surface that to the user. Similarly, if you have default values, like if it's not specified, if you explicitly put that in the schema, we can also surface to the user so they don't have to kind of look in your code to see what's going to happen or go to your documentation. And we also recommend publishing your schema to the URI that you point to within your JSON schema and turn it into a URL. And then when
So this one is a little bit of a security slide. A lot of things that are happening in Windows, you've seen the Secure Future initiative, several other things happening around security. One of the really big concerns here is that JSON file is saying, hey, DSC, go call this executable and pass some arbitrary parameters to it. We don't want some file like that getting modified when we're in the middle of a configuration and all of a sudden bad things happen. We're going to recommend that you publish with packaged identity. That either means publish your application as an MSIX package, everything is contained, everything is isolated per user, we get disk savings, a lot of other benefits. If you're currently a Win32 type of an application, you're unpackaged, that's okay too. We have the idea of packaging with an external location. So your installer and everything still behaves the same way it does, but you're going to have a manifest file that's a packaged manifest that declares the identity. You're going to call that thing at the beginning or the end of your install, and then the actual resource JSON file can be in there. So we have a security digest that we know what the contents are before we try to go access it, and we can make sure that they haven't been tampered with.
All right, so next I'm going to kind of walk through a very simple example of how you write a C#-based DSC v3 resource. So I currently already, I wrote this. It didn't take me that long, but I basically have each commit as individual steps as I work through the process. And if you were actually to dig into the commits, you can kind of see where I reversed some of my decisions, which is kind of fun. But this is currently a pull request. So if I step in the first one, the first two really don't have anything to do with DSC. This is really just building a simple .NET application. In this case, I'm going to make this a little bit smaller so I can see more. This is simply just running .NET new console. That's literally all it's doing, and it's just building the basics for any C# application here. Then the next thing is I wanted to figure out what would be a decent showcase for a resource. So I chose managing Windows services. So here, I'm just using a service controller class, and I'm just enumerating the services. And again, there's nothing to do with DSC so far. I'm just writing to the console a bunch of information just to validate this works. So the next step is where I start moving into how do I DSC-fy this resource, if you will. And again, JSON is the way we transport information between the resource and DSC itself. And luckily, I can just leverage system text JSON serialization class and not have to worry about basically working directly with JSON myself. So there isn't a huge amount of change here. Again, we don't have the DSC integration yet, but this is just starting to, how do we output the information I had from the previous step into JSON? All right, so oh, actually not yet. So I do want to support multiple operations. So this is where I have to worrying about parsing command line arguments. So I start splitting out get, set, test, or in this case, get, set, export, because again, I don't need to explicitly implement test here. Let's see, and then I had created some helper functions. I think the next step is where we start putting it together with DSC, which is the resource manifest. So now that I got it working, I can test it via the command line. I want to now be able to exercise it through DSC, and that's through the manifest. I've also did a bit of refactoring as I decided I didn't like some of the stuff I wrote. So this is one is like, all right, I do need to provide schema. So I'm able to leverage again, there's a C# serialization or JSON schema. So I don't have to do that myself. And basically that allows .NET to take my, in this case, a record and actually produce a JSON schema for DSC to use. And if I go down here to the actual manifest, you can kind of see, again, this should be very similar to what you saw for the registry. In this case, I'm calling this executable that I'm building called Windows Service. For get, I simply have an input argument that's going to take the input JSON that is part of the configuration that it cares about. Export, no arguments for that one. And now for schema, you can either have embedded schema within your manifest, or in this case, because I'm using .NET to actually generate my schema, I'm actually exposing it as a command line argument. So I also wanted to show how do you implement the underscore exists that I mentioned before. So if you were to use the previous step and say, hey, look for this service that doesn't exist on my system, then when I try to query for it via the service controller class, I'm going to get an exception. So I don't want that to be surfaced via DSC, because then it's going to fail the rest of the configuration. Instead, if it's not found, so it's going to be null, then basically I just set this exist to false. And if you look down here, then using this JSON property name, I can rename it to underscore exist, because that's what DSC expects it to be. But I can still adhere to the expectations of what a C# developer would look like, and what would expect it to be in Pascal casing. And then I added a simple example, which we'll run through the examples after I finish going through the steps here. And then next, I wanted to show, all right, what if your resource wanted to do some tracing, making it easier for you to diagnose problems? The way the tracing works is that it is a specific structure for the output on standard error instead of standard out. And I have a helper function, helper functions, that basically for writing debug tracing, writing trace. The main difference between a debug and a trace, if you will, is that the documentation that we provide for DSC is that a trace level, which is the lowest level, is going to be more like raw inputs and outputs, which may contain sensitive information, right? So a recommendation for people using this in production is don't use trace level. That's really for developers. Debug is more like I'm in this part of the code, I'm doing this kind of stuff, which is okay to have turned on if you want to log that stuff, like in CI and stuff like that. All right, and then I decided, you know what, I'm not going to leave set as an exercise to the reader. I'm going to implement it. Probably makes sense. Which is a little bit more complicated. So here's set. You can kind of see I removed the to-do and added the actual code here. And with set, I do have to check. I'd have to do additional checks because I want to provide actually good error messages to the user, like if they didn't provide the name of the service, the status, whether they so exist removal isn't supported by resource. Like you can't say exist is false and expect the resource to remove that service. So I provide a message there. Let's see, anything else that's interesting? The only other interesting thing that I found is that when you don't run elevated and you try to change a service, it's going to fail, but the top level exception doesn't provide meaningful information, so I have to actually get the inner exception to get the actual access denied message. So that's what that additional code on the screen shows. And then let me go through the last one I just did yesterday, because I decided if I'm going to tell you guys to do arrays, I should probably do it for this one. So I'm not going to go through all the code here because I want to get to the demo. But basically now it will accept an array of services instead of just a single service. That way, if you have a configuration that wants to do like SSHD versus WinRM, whatever, you don't have to specify multiple times. So yeah, it required, the diff looks like a lot of change, but basically it's essentially a for loop now, right? So that's the way to think about it. All right, so let's go to here. No, I have to go here. Okay. And then I have to go here. So let me do it here first. I will make this bigger. Sources, Windows. So let's make sure this is built again. All right, so the first thing is the way DSC discovers your resource is via the path environmental variable. So right now, because I'm in this folder, it's not part of the path. So let me just make sure I add it here. So now if I do DC resource list, it should find this new resource, which I called, this one. So this is the one I created for this demo. So one of the things is, as a developer, if you wanted to test your resource, you don't have to write a configuration. You can actually invoke it directly. So let me just run export here against this one. I didn't copy it. Right, so I can do DC resource instead of DC config. And now this is going to run the export operation, and you kind of see it is returning an array. It's not small, and it has. And right now I'm supporting, the name, the display name, the status, and the start type. So if I go in, why does it keep blinking? Let me open this folder here. Let me show some of the configuration YAML examples. All right, let me shrink this a bit. All right. So this YAML shows a couple of new things, I guess. One is parameters. So in this case, I have a status parameter. So this allows me to, as a user, specify if I want stuff running or stopped. And the default is to make it running. And for the purpose of this demo, I'm going to just mess with the spooler service. And on this particular dev box, OpenSSHD or the SSHD service as part of OpenSSH is not there, so it won't be showing. But this is how you reference via an expression and functions. So let's do DC config. Let's do get. By the way, I should mention that if you're using a DSC command line tool directly, you'll notice that by default, it's outputting stuff in syntax-colored YAML. That is because DSC knows that you're not redirecting the output, so it assumes you're doing this interactively, so it's going to make it a little bit easier to understand the output. If you redirect it, the default is going to be JSON lines, actually. So in this case, you see that it ran, there's some metadata in terms of how long it took to run. I'm currently running restricted, meaning non-elevated. A random Windows service, and the print spooler is running, and it's set to automatic. And guess what? The exist worked because it says SSHD is actually not on this particular system. Now, if I wanted to run set, I need to do a couple of things here real quick. So as I mentioned, set doesn't support, oh, actually, this is fine. This is running, so I can do this, and it's going to fail because SSHD isn't on the system. But I have to be elevated to run set, so I'm going to use this elevated window. Let's go back to that repo. Let's see. Let's add that path back in. Let's make sure it finds it. Yep. So let's do a set. So it's going to fail because, like I said, SSHD is not in the system. I can actually make this a little bit more interesting by removing this for now to show I can use this to start and stop the spooler service. So currently, as you recall, there's a parameter, and it is running, and the default is running. So if I wanted to say, make it not running, meaning stopped, then I can provide arguments here. And this is going to be, so this format of the parameters is going to be the same as in ARM templates. So there's a parameters property, and it's going to, whoops, yes, status, and I want it stopped. So if I did that right, then it was running, and then after I did this, it's now stopped, right? So you can, well, I can just do get service just to prove, no, I'm not cheating here. The other thing I want to show real quick is test. So here, again, I removed the SSHD side. So remember the original configuration document expected to be running, it stopped, and so in desired state is false. I also have another example where it checks for a non-existing service, so it does not exist. And in this demo, I want it to be true, meaning I want the service to exist, and obviously this thing doesn't exist, so it's false. So that covers that. And I think that's the end. You want to close out?
Yeah. So we're going to open up for some Q&A. I'm going to go ahead and leave the last slide on as some of the resources that have links to some of the things that we've talked about. Everything is documented on Microsoft Learn for everything that is in stable WinGet. So everything you're going to see there today is referencing DSC v2. When we release WinGet 1.11 at the end of June, we'll update everything to show how the support for DSC v3 works and how everything works with hybrid configurations where you're mixing and matching v2 and v3 resources. All of those samples on GitHub with the aka.ms/winget-samples are out there. Feel free to add more samples if you've got some ideas. If it's not clear enough, file some issues. We do pretty much every bit of this open source, and we're looking for community feedback and engagement. We've also got links to the Microsoft desired state configuration documentation and the PowerShell DSC repo, where everything that Steve and team are building is also open source. So if you've got any questions, please step up to the microphone, and love to hear what you have to ask.
Hey, I got two questions for you. First question is, does DSC3 support internal proxy usage?
What was that? Internal
proxy?
Oh, proxies?
For the package management side of it?
So I think proxy support, I don't know if, is this more of a question about the WinGet resource or DSC itself?
I guess it would be more of a WinGet question than a DSC3.
So WinGet has proxy support for anything that we're pulling through the network through the proxy setting. We haven't done a lot of testing with proxies on DSC v3. Okay. We have had a few customers that have said things like, hey, some of my stuff needs to come from this proxy, some needs to come from that proxy. So we haven't figured out how to deal with multiples. But if you've just got the standard proxy configuration in WinGet, when you call the DSC resource, it's going to inherit that default state.
Gotcha, thanks. And the other question I had was around Linux support for DSC3.
Linux support?
Oh, Linux, yes. Oh, so one thing that I guess wasn't very explicitly mentioned, partly because maybe this is Microsoft and Windows, but DSC v3 project is designed from the beginning to be cross-platform. So we do have binaries already available for Linux and also Mac OS. For Linux, it's actually we decided that all the dependencies are all statically linked. So whether you're using something that is glibc or muscle, it should just work. That's what we test against. So if you have any problems, open up issues in the DSC repo. So we do explicitly want to support Linux. So hopefully over time, we'll see also Linux resources.
Yeah, something else that may not have been super obvious, I think I forgot to mention it. All the demo that we've been doing today has been on one of the new Copilot Plus PCs. This is one that's got Snapdragon and the NPU. It's ARM64 architecture. The dev box that we did everything on, where you just saw me dragging and dropping and running everything, that's x64. That's on different silicon. I don't know the last time I've ever seen I can take a logical backup from one architecture of silicon and go apply that to another one. So let's say you've got a PC at work, you've got it set up the way you love it. You can export everything using WinGet. When you get a new device, even if the processor architecture has changed, that configuration will work. The only caveats are, in some cases, there may not be a native ARM64 binary, but with the x64 emulation, everything should just still run. Until those things get converted to ARM native, you may see a little bit less battery life and maybe a little bit less performance, but I've never seen anything like this done before. Go ahead.
Has there been any thought about being able to configure or install fonts? Programmers love their own choice of fonts, and I'd like to be able to have consistency between the number of machines that I use.
Absolutely. That was one of the top features at WinGet for several years by vote of thumbs up. We actually have an experimental feature right now that will list fonts. It will tell you all of the font families and how many faces are installed. We've got a little more work. There's an open PR for actually doing the install and the upgrade and the uninstall behavior. And then the last bit of work is going to be going out to the WinGet packages repository. We don't want to mix fonts and packages. There could be namespace collisions there. So we're going to have a fonts directory that we're going to allow you to submit whatever fonts you want. And just like that is another source, if you're an enterprise and you're developing fonts and you've got a lot of custom things and you don't want them going out, again, you can stand up your own private REST source. You can load those fonts in there, and you can commingle them with packages. Just beware of potential for namespace collisions. And with the Entra ID support that we built in the REST source, not only is the manifest data about the existence of the fonts and their paths protected, but the Entra ID authentication also can be required to actually download and install the font.
You want to show them how to WinGet features or show?
Sure. So the question is kind of going into some more details on WinGet features. We built quite a few conveniences in WinGet. So I'm going to go ahead and clear the screen here.
You want to switch?
If I run WinGet info, essentially what's going to get displayed here is all of the version information for WinGet, the version of app installer that it shipped in, the system architecture, and then I can see all of the directories that are present for where WinGet deals with all the files. We've got several links for information for you to go get more. You can see admin settings here. The admin settings require administrator to enable or disable, and they can all be controlled by group policy. If I run WinGet features, this is going to show any of the experimental features that we have enabled or disabled. And you can see from the font question earlier, font is on the kind of the bottom of the list right now. Position doesn't mean it's higher or lower priority, it's just wherever it is in the code. And then if I can get the dev box to connect back up again, then I'll go in there and show you the differences where you can actually see the ARM64 architecture, or the x64 architecture as opposed to this device that's ARM. And in my WinGet settings, we do have a schema, so there are several other things that are in here. One of the other common ones is network. And there's a downloader property. The default one is delivery optimization set up for enterprise use in the future. The other one that you can select is WinINet. Sometimes we've seen some cases where some policies may interfere, so you can change those network settings. But you can see the IntelliSense is here with everything. We've been doing a lot of work to make sure that everything has got a schema, everything is completely documented. You can go and look at it. If you see gaps in that, be sure to file issues on GitHub. One of the other really popular things that we've started seeing happen is people building configurations inside of their projects at GitHub to kind of really help us realize this vision of configuration as code. If I go look at 𝗦𝗲𝗀𝗀𝗀𝗀 and I go look at getting started and I say that I want to contribute, fork the repo, clone the repo, run the WinGet configuration file inside the project. This is really where we see the future of things going. A lot of people get interested in a project that's open source. They want to go contribute. You've all seen the crazy readmes or having to go 9 links deep to go find the things you're looking for. My vision here is we've got everything checked into source control, and it's basically run the configuration, You can F5 the project, you're ready to go. If you think something has changed, you can run validate, or you can just run the configuration again because it's idempotent. And that becoming part of your normal workflow guarantees your system is in the desired state. All right, well, if there aren't any other questions in the room, we'll go ahead and wrap up. If you want to talk privately or have any more detailed information that you want to get, Steve and I will be outside in the hallway. We're going to get unmiked, and then we'll meet you outside in a few minutes. Thank you, everybody.